Hello, I'm Jenny Brown from the National Oceanography Centre. There are many different coastal models that can be applied to answer different management or research questions. Here we will briefly run through the data requirements for the different types of model. Models require data for calibration and validation purposes. They also require data to provide a boundary forcing. This data may be from observations or other numerical simulations. Observations can be limited in time and space, as it might depend on when a cruise has taken place or when a mooring is deployed. This is why other numerical data sources are often used to help fill gaps and extend observational information. Coastal evolution models are used to simulate long-term changes in shoreline position. They require information about the near-shore wave climate to drive the model and long-term shoreline position to calibrate the model for historical rates of evolution. This data often comes from nearshore wave rider buoys and aerial photography. Cross-shore profile models are often used as a computationally efficient way to assess storm impact. The outputs of interest are typically the event-driven erosion, wave run-up, and overwash values. They require information about the beach profile and the combined wave and water levels offshore at the depth of closure. This data is often collected from beach and bathymetric surveys and joint probability analysis of closely positioned long-term tide gauge and wave rider records. Coastal area models can be used to assess the contributions of different processes to the hydro and sediment dynamics across a region. They are computationally expensive, so are often limited to the simulation of a few years. These models are typically applied in a nested approach to allow high resolution at the coast. They require large-scale datasets, such as maps of bed characteristics, to provide input data. National networks of tide gauges and wave riders are typically used to validate the wave water levels results. Additional information collected by satellite and observational campaigns can then be used to validate temperature, salinity, and velocity fields. Inundation models provide information about flood extent and depth. When combined with knowledge of the land use, an estimate of potential economic costs of a severe event can be determined. Inundation models extend inland, typically from a defence crest level or the low water mark. The boundary forcing requires information about the overwashing or overtopping volumes of a defence. A map of the topography and changes in land use are also required. Very often this is determined from LiDAR data. Validation data can be difficult to obtain as it requires information on waterlines and drift lines, which need to be collected before they become cleaned up. Operational models and climate projections provide a useful long-term data source over large national and regional scales. They enable simulation of past, present, and a range of plausible future conditions to be explored. The data is often available at different resolutions. When using this type of data to force your model, it is important to consider where the boundary is positioned relative to the data points available, and if you are looking at changes in climatology, such as winter and summer conditions, or require the resolution of events such as storms. The key messages from this presentation are: you should consider which model is suitable at answering the question being asked. You can then determine what the data requirements are and if they are available. Then you can select a suitable model for the application. In some cases, more than one model may be needed to provide a detailed answer.